giving you a little bit of insights into what does it take to build a system that revolves around AI or ML. And the first thing that I wanted to highlight about this is building such systems is not only actually about building models, it's about building an end-to-end system. This means that you need to think about like things like what are the user experience would be, what are the product requirements, and this is actually what does it take to be an ML engineer. That's a different role than being a data scientist, where the data scientist has like the top goal or the North Star metric is improving the model. Anyone who's working on the engineering side should be thinking about owning the problem end to end and building the whole system rather than building just a model only. Of course, building the model is a very crucial part, but it's not the only part that is out there. So my goal more specifically for today's session is basically providing you with a framework or an approach that you can take and adapt for your own specific problem that will help you as an ML engineer or backend engineer who works with ML. Will help you to scope AI and ML projects. The details, of course, can vary from one project to the other. So take this and adapt it. It's not like set in stones. Um, the It's not a goal of today's session is to basically none of the it's not a goal for this session is to do a deep dive into a specific product or a specific model or a specific problem statement. We will use one project as an example rather than just giving you like very abstract ideas. We will use a specific problem, but the goal is not being an expert in this specific problem. Instead, it's just used as an example. So that's the goals and the objective. And I want to reiterate something one more time: is whenever you get a, let's say that you're working as an ML engineer in a specific company, and you are given a problem statement by your engineering manager or your leadership or your product manager, what would be the first thing that you would do? So let's say that you're working as an ML engineer, you're handed a project. We need to build system that does XYZ. What is the first thing that you will do? That's a question for people. I want to hear people's thoughts. Feel free to drop your answer on the chat. Given a problem statement as an ML engineer, what is the first thing that you will do? We will see sample example, but I wanted to hear people's thoughts. Business requirement, yes. Thanks, Suman. Yes. Requirement analysis, yes. Understand the data. That should come after understanding the business problem. Deep dive into requirements, yes. Analyze and capture the requirements. System design will also come after the understanding the requirements, but I think everyone kind of agree. Data collection will also come after understand the requirement, because if you don't know what exactly you need to build, you'll not know what data you need to collect. So I think everyone is revolving around 2 points: understanding the requirements and understanding the data. I think understanding the data should come after understand the requirements. I'm very glad that everyone gets into the right points. Whatever you do, please do not jump directly to the ML modeling part. I have seen this happening a lot, where people, especially people who are new to ML engineering, get too excited about the model and the options that they have, and they start making deep dives into the choosing the ML model. This is wrong on multiple levels. First, you don't know which model to choose or which approach to choose if you don't deeply understand the business or the engineering problem. So you basically have to first think carefully about what is the problem that we are solving. This is because whoever is handing the problem to you actually doesn't understand ML that much. They understand a business problem, and it is your job to work with them to understand the business problem. And based on that, you figure out how actually ML can help. This increases the chances of success for your project, because I have seen projects where people build cool ML models that work very well on offline data, but once you deploy them in the product, it doesn't add a value to the product, if not actually making it even worse, because it consumes resources and impacts the user experience. So training the model is important. It is hard, but it's not the most important part. It's not the hardest part. Framing the problem that you have as an ML problem and figuring out exactly where ML can help will be the trickiest part that require people who understand ML engineering and product as well. So this is where you can actually shine, and you basically, if you speak these different languages, product, and business, and the software engineering and ML, you will be in a unique position to deliver a value to your organization. So this would be your first thing to do. Um, Understand the business problem and understand exactly where your model or where ML can help. Based on that, you can frame an ML problem that achieve that goal, and you get other benefits as well, which is basically you know exactly what to monitor. Let's say that you have built the system and the model is deployed. You want to know whether the model is successful or not. If you identify these steps, you will be able to monitor exactly the behavior of your model in the production. uh, can folks hear me clearly? People are saying there's a bit of echo. Can you hear me?
I can confirm that I can't hear an echo.
You can or you can't?
I can hear you clearly. Karthik, I think you may have to check your system or maybe re-log in once, bro.
Okay.
Totally fine, Ahmed.
Okay. If there are any issues, please ping me. I want to make sure that people can hear me and see me. So yeah, thanks for the heads up. Okay, cool. Okay. So with that being said, we identified that the fact that we want to identify where the ML can help, and we want to frame an ML problem. Since today's session is more on the GenAI design, there will be specific concepts that we will talk about a little bit. Maybe some of these can will be new for some folks. Some of these will already people will be familiar with. But I wanted to highlight these concepts that we will talk about for specifically for GenAI system design, retrieval augmented generation, different prompting technique, and tool call. I will briefly explain these just in case if anyone is not familiar with them. But we will explain this as we go through a problem statement, just to make things a little bit more concrete, rather than being very hand wavy and very high level. So let me start. Let me share a problem statement with you. The problem that we worked with today, which is basically design a system that generates personalized health and wellness articles for users in real time using GenAI. So one thing to notice here is that the problem is steered more towards a product problem or a business problem or a feature driven. Of course, towards the end it says the word GenAI, but it doesn't give you like details about how to do this exactly. And this is a very typical thing. You, as I mentioned earlier, you get your engineering manager or leadership or product partners and say like, we want to develop this feature. Go ahead and figure this out for us to basically what to build. And it can be actually a bit overwhelming. This example is a little bit easier, but in reality, it could be overwhelming if you get like a very vague problem and you are not so sure where to start. If you ever like have this situation and you feel like, okay, the product team needs to build something and they have no idea where to start, I think it's a good idea to start partnering with your product team to better understand the problem or scoping the problem, and some concrete steps that you can take just to get started and make things a little bit concrete is first identifying what is the input to your system. Then you identify what are the outputs, and that will make the model will give you like a more or a better idea about what the model exactly is supposed to be doing or your system is supposed to be doing. So let's do this exercise together. For this problem statement, I will put it on the screen again so that people can see it, which is basically designing a system that suggests health articles for users. For that system, what will be the inputs to that system? What do people think? Health data, areas of interest, knowledge base, personal details. Okay, monitoring health parameters. Okay, so of course we assume that there's input data that we want to consider, right? These are the inputs that we will, or the database that we want the system to consume. But in addition to that, we have the inputs from the user, or basically the user profile and or preference and the user question. In addition, of course, to some health data, right, or health articles. Basically, we have these health articles that we want to use. Could be from WebMD or whatever public data or private data set that we have that we want to use to factually give correct answers. In addition to that, we have the user profile and the user question, right? And then based on that, we can think about the output, which is relatively easier to think about it. The output in this case will be a personalized, medically reliable article. You can add something as like factually correct to the requirement or to the output, factually correct, since we already talked about the fact that we will have some data sets as an input to our system. So this hopefully will give you an idea about here are the inputs that we need to process. That's the output that we want to produce. And then you can think a little bit about what people call non-functional requirements. I'm not going to expand on these because it's not the main goal of the session is to list all the non-functional requirements. But can people list one or two non-functional requirements for the system? Reliability is one thing, yes. Latency is very important because we don't want the system to run for a long time because this will impact the user experience. What else? Security. This is extremely important. We don't want people to lose their data or data privacy because maybe it contains some sensitive information. So there are like lots of non-functional requirements. I'm not going to list all of these, but people already listed some of the good points. Like basically we don't want the latency to exceed a specific latency budget, let's say 500 millisecond. We want the answer to be factually correct. We can add something related to reliability and throughput of the system. So that's basically the scoping the problem, and in reality you should be working with product team and eng teams to specify these requirements. But let's say that moving fast forward, we identify the requirements of the system and we need to think about the key components that will exist in our system. So we identified basically we were thinking about the problem as having like a black box, which is the model itself or the system that will generate the responses. We know what are the inputs and we know what are the outputs. Now we will start thinking about this system. And the very first step is identifying the main components in that system. So for that specific system, what would be the main components that are out there? LLM, right? The LLM, this is GenAI, so I think it's very reasonable to assume that the LLM will be the main component in the system. Of course, there are other components that we will discover later. So the main component will be LLM. Do you folks think that LLM alone will be enough for the system? No, right? Like it's not going to be enough. And why is that? Right, because it misses some of the it basically LLM doesn't have access or doesn't know about the custom data sets or custom articles that we want to bake inside the whole system. So basically one of the questions that maybe to illustrate this idea, if the user asks some question like I have these symptoms or I have like this blood pressure, is it too high or too low? The model doesn't necessarily know the answer because it doesn't have access to the web articles or medical article or the data set that we determined are the source of truth, and we want to basically the model to consider them. Some folks are asking about what is the problem statement. The problem statement is as simple as building a system that recommends health articles for people, and here's exactly how the problem statement looks like. So basically, we want to generate personalized health and wellness articles. Okay, so we talked about the fact that LM alone will not be enough. We need to have like the custom knowledge base. And the first question is, what are the options? I know that people are mentioning one of the approaches, which is the right approach, but what are the options that we have to let the LM know about this data set? What would be the options that we have? Train the model or fine tune the model with the domain data that we have. Yes, this is one approach. Um, and basically, this is called fine tuning. Again, this is not the only option. This is not the option that we're going to talk about it, but to be aware of the options and evaluate them against each other. So the first approach or one of the options is basically fine tune the model on the input data set that we have. You can think, for those who are not familiar with what is fine tuning, it's basically taking a model that has been pre-trained. You can see that I'm highlighting that this is a pre-trained model, uh, and adding additional data sets to that model so that you have a specialized model. So you can think of this as like a student who finished undergrad, and this is basically a new niche domain, and that student learns about this domain and become like a grad student or has like a graduate degree in that domain. That student with the new information has to remember everything that the student learned in the past through the pre-training. But in addition to that, the student should be also an expert in a specific niche domain. This is very important because one of the challenges with fine tuning is basically what people call catastrophic forgetting, where basically the model learns the new data set and forgets everything it learned before. It's as if the student learns only the things in the grad school and forgets everything that they learned through undergrad. It's a challenging problem that has to be balanced, and has like the training recipe or the training procedure has to be tailored or tuned carefully to address this issue. This is one of the challenges with fine tuning. Of course, it requires also refine tuning the model for each task independently and differently, which also increases the difficulty of this problem. So you can think of like this conceptually, that we have on one hand, we have an off-shelf model that doesn't understand our own data set, and it just hallucinates. And then on the other end of the spectrum, there is another approach which fine-tunes the model, but it's expensive and it's a little bit hard. And the approach that is in between, which is basically retrieval augmented generation that people mentioned in the chat, is trying to basically say, I'm not going to fine-tune the model beforehand. I'm going to show the model the correct or the relevant answers on the fly during inference time once I receive the user question. Once I receive that, I will basically pull the relevant information and pass it to the model at inference time. I will explain that in detail, but let me take a pause and see if there are some questions on the Q&A, just to make sure that if there's anything that people wants to discuss. Let me resolve some of the answers. It will be easier for me if you please put the answers on the chat so that I know exactly what are the questions that people have. There are some questions. What is RAG? I will explain what is RAG in a minute. What is inference time? Inference time is basically when the system is deployed and it has been used, and then the user submits a question, and we want to run or ask the model to answer this question. um, what is the difference between RAG and fine tuning? Basically, I explained fine tuning. I haven't explained RAG yet. So basically, fine tuning happens before you deploy the model, where you update the model weights to bake in or add the information here inside the model, and you get a customized model. RAG doesn't do this, and I will explain RAG in a minute. Um, let's see. Is this RAG session or agentic AI session? We are going to talk about both. We're going to talk about RAG, and then we're going to talk about um, and then we're going to talk about agents. Let's see if we have other questions. How to choose between fine tuning and RAG? I will get back to this question once I explain RAG. Let's see. Let me just resolve some of these answers. Okay. Deployment problems, particularly when we deploy RAG and agentic RAG AI systems, please explain all issues. We will get into this towards the end when we talk about the operations side. And another question about deployment. Yes, I will talk about deployment, safety, and security towards the end. We have this. What is off-shelf LLM? Off-shelf LLM, you can think of this as OpenAI models. OpenAI model, like 4.0 or 4.0 mini. Or you can think of this as Gemini or Claude or any of these models. These are models that have been trained for us, and we can use them directly through an API, or if it's an open source model, you can download it and deploy it locally. Okay, so basically that's the idea. Where basically we're talking about an example problem statement where you have a system requirement, and we're talking about how to think about this problem or how to address this problem as ML engineers. The problem that we talked about is recommending or generating health articles for users based on their preference. And we explore the idea that we will identify the inputs to the system and then the outputs to the system. And we explore the options with the main components. We found that the first component is the LLM, and we found that the LLM alone cannot answer the questions directly. And one of the options is to add the data set as fine-tuned data set. The other option that we talked about is retrieval-augmented generation. And the idea of retrieval-augmented generation is, instead of doing a fine-tuning before we deploy the model, we're going actually during inference time, from the moment that the user submits the question. So the user sends a question here. Um, Between the moment that the user sends the question and the moment we send the response back, we're going to query that data set, pull the relevant information, and send it uh, to the off-shelf model or the pre-trained model. I will dig deeper into the different components, but that's the main idea, that you do this at inference time, not before deploying the model. Let's look at a more zoomed in version of that figure, where you basically have the input user question. You go ahead and ask some system. Let's abstract this as a storage system that it contains our data. We will talk a little bit about how this is being built under the hood. And then this custom storage system returns to you the relevant documents that can be used to answer the user question. That's basically the general idea of the RAG, or retrieval augmented generation. You go ahead and pull the relevant information, and you add that relevant information to the prompt that you send to the LLM, which gives us what we call augmented prompt. So how does that augmented prompt look like? Let's take a look at one specific example. So you can see here, for example, that the augmented prompt contains instructions to the LLM that says, answer this question based only on the provided context. And then eventually you have the user question, what are the symptoms for high blood pressure? And then you have this context that we pulled from the previous step from that vector store. You can see that this context will depend on the user question and on the retrieval system that we added to the or on the storage system that we added to our system. So basically, the it's two-step process. You pull the relevant information, you append these to the prompt, which gives you what we call augmented prompt, and then we send that to the LLM. So you can tell that this storage system is quite important. We have to build it in a way that it's capable of retrieving relevant documents, not only based on the text or on the textual similarity, but also based on the semantic similarity. In another word, we need to build that system such that it is fast enough, because it is on the critical path from step 1 to step 5. If it takes too long, then it will impact the user latency, or the user perceived latency. And also, it has to retrieve the articles or the documents that are based on the semantic similarity, not only based on text. So, for example, if we have two words, word like car and word like vehicle, they are representing the same concept, but they are different words. We still want to consider these as very relevant to each other. So basically, we want to build that system such that it captures the similarity. What is the right way to represent text so that it captures the similarity? Let's see. We got some of the correct answers. Yes. Okay. So some folks already know the concept, but I will reiterate the idea one more time, because some folks are asking, what is the vector store? The vector store is the storage system that we will explain in a minute, but you can think of it as a storage system, storage and retrieval system, that is capable of taking a user query and returns the relevant document based off of that query. Obviously, if we compare the user query to the candidate documents word by word, it will miss the semantics. It will not return documents based on the similarity or the semantic similarity. And my question was, what should we rely on to retrieve the relevant documents instead of like word-to-word matching or word or text comparison, direct text comparison? And some folks suggested that we should be relying on embedding representation. So basically, for those who are not familiar with what is embedding, embedding is a technique that represents words using vectors or list of numbers. Let's see. Uh, Okay. So basically, it is a representation for words or input text that captures their meaning. It's a list of numbers. That's why we call them vector, because in math, a list of numbers is called vector. Even in C++, a list of numbers are called vectors. The whole idea is we want words that are very close to each other to have a representations that have high similarity. So a word like New York and a word like Paris have high similarity because they represent a concept of a big city. So we want the representation of these two words to be closer to each other. There are some mathematical formulas to compute the distance or the similarity between two vectors, like something like cosine similarity. But basically, any similarity metric can be used here, and we want the representation of these two concepts to be close to each other. Similarly, the word animal and word horse, we want the representation to be close to each other because they represent similar concepts. On the other hand, we want the representation of the word New York and the word animal to be low because they are presented two different concepts, and similarly Paris and horse. So that's the idea of embedding. This is done through completely different models than the LLM. Examples are BERT models, which is completely different than the LLM. It's not the same LLM, it's not the same model. It's a machine learning model, but it's not the same as the LLM. So basically, it fits here in the bigger picture. It fits here. It's inside that storage system. The embedding happens inside this step, and more specifically, what happens is um, do you before you deploy the model before deployment, you take all the relevant documents all the health articles, and you run them through embeddings one by one. And for example, as a toy example here, we have only three documents. So we have three embedding vectors, and we generate these three embedding vectors before we run the system or before we deploy the system. Once we get the user question, remember that the first step that we wanted to do here is basically go ahead and talk to the vector store and ask it to return to us the most relevant documents, right? Between step 2 and 3, what actually happens is, if you look here, you will take the user query, you'll run it through the same exact model that you used for offline generation, because you are going to compare the embedding representation of the query against all the relevant documents that you have. And based on that, you are going to return the most relevant documents. So basically, the comparison is based on some representation that captures the similarity instead of relying on the exact text, which can miss the similarity or the content or the meaning of the text. Okay. So I have one question for folks, just to make sure that we are all aligned on the same page. Once the vector store runs, and by the way, before the question, we call it vector store because it stores the vector representation or the embeddings in addition to the original text. So both of these are stored. You can think of the vector as the key that is used for the retrieval or the comparison, and you can think of the text as the value. It's not a key value stored, but you can conceptually think of it as this way. Basically, the key is the thing that is used for determining the how close each candidate to the query is the embedding representation, but the text is also kept there as a value. So based on that, what does the whole vector store return? What is the thing that this vector store returns? Let's see. What is returned here? Closely matching data. Yes. What exactly is being returned in that matching data? That is correct, but I want to know exactly what is the type of the data that's being returned. It returns the score, but we need the original data to be returned as well, right? Let's see. Yep. So it basically returns the text, not the embeddings. I'm glad that most people got this correct. Some people got confused that they think that it returns the embedding. It doesn't return the embeddings. The embedding is there, but we do not need it. And we do not need it because we mostly are going to use the output of the vector store to augment the prompt, which is in text. So that's the main goal, which is basically returning the closest text that is associated with these embeddings. or the closest text to the user question. Let me take some question in the chat because I see some interesting question. One of the questions that says, how vector database knows these are city names? Do we pass labels data as an input vector to the database? No, the vector store uses an embedding model that is pre-trained as well. So if you look here, you will find that this is using a pre-trained embedding models that have seen tons of text, and it knows how to map this word to a vector that captures that meaning. It doesn't directly tell us that this is a city name, but it knows that these two concepts are closer to each other. If I ask a question, how does it know to retrieve the answer from a specific document when we're using a cosine similarity? So for example, if we compute the pairwise similarity, and the highest similarity was between the question and the first document was zero point 0.9, the other one was zero point 0.7, and the third one was 0.01, then obviously this is the closest one, and it returns the top one. You can return the top two, the top three, the top k basically can be returned. Um, okay, so basically the whole idea is we rely on the vector store, which encapsulates all the details related to the retrieval. It's a bundle that contains the storage system and the embedding model that can be used to do two things. First, storing your original text along with the embeddings of these text, and also running the comparison and efficiently, because they use some approximation algorithms to make things a bit faster, and they return to you the text associated with the closest content. Let me uh, let me take some of the questions because we're going to shift gear. One important question: how to decide when to use what, RAG versus fine tuning? This is really a good question. Typically, people like, I think the best practices for the last year or 2 years actually is starting with RAG, retrieval augmented generation, and see how far you can go, or starting with agents and prompting, not only RAG. This is mostly because fine tuning is expensive, and you will need to fine tune a different checkpoint for every problem that you have. So I think the best practices have been starting with prompt engineering in general, RAG or agents, as we will talk about in a few minutes. And then if you really need to do fine tuning because you have a very niche domain, or you want the model to change the style of the tone that is being used, then you use fine tuning. Um, Another question: can we directly have customized pre-trained data LM and not pre-trained LM before that? Sorry, I'm not sure what do you mean by having customized pre-trained data LM. You can have your own pre-trained LLM if that's your question, that you train on a custom data. The content that goes from RAG, does that also add to the number of tokens going to the LM? Excellent question. Yes. The final prompt will look like something like this. And this, of course, adds to the number of tokens that go to the LLM. And almost all LLMs have a limit on the number of tokens. So you should account for that. Otherwise, the input will be truncated. Let me resolve some of the answers that people added just to see if there are any interesting questions. Uh, this is a repeated question. How to determine which vector storage to use, and how to determine the embedding and retrieval strategy for structured data. These are a bunch of hyperparameter tuning that you have to take. You have to try different embedding models. You have to try different like top K, top 2, or top 3 results that you want to return. And it takes a bit of trial and error. Can we have the PPT? Okay, I will leave that question for Rohan to answer. Okay, so I think how we let open AI LMs know our own vector database. You don't. You do not let you don't have to let the if basically if you're using this from OpenAI, for example, then they don't need to know anything about how you retrieve the content. As far as they are concerned, you will pass to them piece of text, and then they will give you an answer based off of that. So basically, the implementation details on how we retrieved the most relevant documents doesn't matter, because eventually you will have text returned from here. Is BERT the only embedding model out there? No, you can use OpenAI embeddings also. When does the LM decide that it has to call a RAG? Excellent question, and a really good segue to my next point. So far, the LLM actually didn't decide whether it should be calling RAG or not, or calling the vector store or not. We did as engineers who wrote the system, because remember, like, we have an application here, which is a backend server that receives the question from the user, right? And right away, it called the vector store, pull the relevant information and pass that to the LLM, right? So the LLM didn't choose anything, which is a limitation in itself, right? There are multiple limitations here actually. The first one is, what if there are multiple data sources and we want to choose between these different data sources dynamically based on the user question? This is not doable using this architecture yet. What if the information, what are the other, let's ask people actually, what are the other limitations of using RAG? One of them is not allowing multiple data sources to be called dynamically. What else? Please put your answers on the chat to make it easier for me to keep track of the questions. So what are the other limitations of retrieval augmented generation? There's an obvious limitation, and I want to see if people have context matching might not be accurate. Yes, this is the bottleneck on the quality. What else? Uh, hallucination, chunking of text. Okay, this is also, I was looking for a specific thing which is basically related to recent information. If we have new information that needs to be ingested on the into that vector store, it might take a bit of time. Think about, for example, if I'm asking questions related to the weather. Obviously, I cannot ingest the weather predictions every minute or even every hour. It doesn't scale. And yeah, scalability of ingested data as well. So basically, one of the limitations is not being able to dynamically use different sources or different data sources. And also, the freshness of the data is quite limited to the ingestion process that we explained here. Sorry. Yeah, it's limited to the ingestion process or the pace of the ingestion process that we listed here. So people realized that maybe we should be thinking about different data sources rather than only this one data source that we talked about. And we can think about data sources as tools. They started using the word tool. You can think of tool as programmatically as an API or a function call. So basically, you have a data source that you can pull information from it or data from it using an API call or a function call, where we are going to abstract these as tools. And we will let the LLM actually decide which tool needs to be used based on the question, rather than us as engineer deciding upfront that this is the only source that we will need to that this is the only source that we'll use. Instead, we're going to actually rely on the LLM to dynamically determine which tool or which data source needs to be used. So the flow will look like this. First and foremost, remember that everything starts through an endpoint that your backend server exposes. So the entry point that receives the user question is a backend server, not the LLM. And once the backend server receives that question, it will forward it to the LLM. And the LLM will not call the tool. Remember, the LLM doesn't have the capacity, doesn't have the ability to call to call a tool or to call an API or to call a function. Instead, the LLM can choose which tool needs to be called, which tool needs to be used, and it will return to the backend saying, "Hey, I need to call this API or I need to call this tool with these parameters." So additionally, it will return the list of parameters based on the user question. So, for example, if there are three APIs, one for the weather and one for like Google search and one for shopping information, and the user is asking about is it going to rain or not, then the LLM will make the choice that the second and third APIs or tools are not relevant. I should actually call the first one. It will return the name to the backend. The backend is a regular C++ or Java or Python implementation that can call a tool if it knows its name. It has a mapping between a name of an API and the actual endpoint, and it will just forward that to one of the tools. The tool will return the response to the backend, and then the backend will make another call. So this is an LLM call, and it will make another LLM call here saying, this is the original user question. You asked me to call this tool. I did call the tool for you, and here's the output of that tool. What should we do next? So you can see here that the LLM is not only being used as a final response generator, but it's actually being used as a planner that plans for me which tools or which APIs or which functions need to be called to pull the relevant information so that it can answer the final question. And actually, these steps from 1 to 5, all of these are one. People refer to this as one reasoning loop. This reasoning loop can be repeated a few times. Can be repeated 1 time, 2 times, 3 times. The LLM can ask for a specific API to be called. It gets a response. It decides what to do next, whether it needs to call another API or not, till it reaches a point where it has all the relevant information, and it just returns saying like, "Okay, I'm done. I don't need any more information." You can actually forward the response back to the user. And this is what people, that whole process, people refer to it as agents with tools. So agents are actually LLMs with tools, with access to tools through that custom implementation that we have. I'm going to take a pause because I'm sure there are lots of questions here. So let me go through this. This is answers. Are there different types of RAGs? No, I think it's mostly one type of RAG, and then people moved on to agents with tools. Is there a pattern how the RAG output is constructed as a prompt? Mostly it's used within the prompt that I showed to you earlier, where you give these system instructions to use the output from RAG, and then you ask the question. Let's see. If the data is not updated frequently, it typically makes the LM a foundation LM itself. I'm not sure what do you mean by that, but if the data is not updated frequently, then we will not have a problem. But if you have a scenario where the data keeps updated, then you need to ingest the new data or use tools to pull the relevant information. Is there a practice of using different pre-trained LLMs to augment each other? You can have a multi-agent system where you can have different LLMs that answer different types of questions, but if you want to do this, you have to think about how to route the question to the right sub-agent. Can we fine-tune the parameter to learn our custom data? Yes, you can do this, which we refer to as fine-tuning, but it's expensive and requires a bit of skills. And it's not actually either or. You can fine-tune a model and use it to power an agent or to power a RAG system. Is it possible to fine-tune, train the LLM, since LLMs take it is possible to do that, but it will take a bit of time and cost as well. Uh, let's see. If I'm building a RAG for a financial use case, I am dealing with uh, some sensitive data. Is it okay for data to go through the LLM from a security point of view? Really good question. Some domains require the data to not leave the network. In that scenario, you have two options. Either you use some cloud providers that provide private network, VPCSC, or you have to deploy it locally on your machine or on your servers that live within your network. Right. What are the most efficient AI ML tools for system design in market? So I'm not sure what do you mean by efficient tools for system design. Are you talking about like studying or actual systems that we can use? Okay. While constructing system prompts, do we have to supplement it to ensure it is grounded based on facts? Yes. And this is a good, like, basically, really good question, because this LLM here doesn't know anything about your problem space. It doesn't know anything about your data sources. It doesn't know anything about the tools that are available that it can tool. All what it knows about your problem comes from the prompt. You have to pack everything in the prompt, and this is where prompt engineering comes into the picture. You have to add everything into that prompt. For example, the question that you ask the LM, like what are the data, what are the tools that I should use to answer this question, requires a specific prompting technique, which people refer to as React. I'm not going to get into the details of React and how it looks like, but generally the idea is you list the tools or the actions that the LLM has, and you ask it which tool I should use. So basically, you have the system instructions telling the LLM what is the problem that you're asking it to solve for you. And based off of that, you tell it, here are the tools, here are the list of available tools. Tell me or let me know which tool should be used. And based on that, for example, the tool, the LLM can choose, like, you have to call the search tool as step number 2. Or in a different scenario, it will call, you have to call the lookup tool. As output for step number 2. Or in another scenario, it will say like, finish. I have all the answers. I have all the information that I needed. And you can actually forward the response back to the user. So there are lots of efforts in packing every piece of information that you want the LLM to know in the input or in the prompt, which people refer to as prompt engineering. If you're interested, you can read a little bit more about React style prompting, but it's basically the backbone of building agents with tools. So that's basically a very, very quick introduction to retrieval augmented generation and agents. Of course, there are many details that I didn't cover, but I wanted to leave sometime towards the end for two main things: operations, safety, and security of these LMs. And then I also wanted to leave some time for folks to ask questions. The first thing that I want to talk about is operations or LLM ops. It's very important to realize that as an ML engineer, your job actually doesn't end once you deploy the system or the model. You actually need to follow through the model. You need to monitor the performance of the model and know whether it's doing what it's supposed to be doing or not. And this is actually will be determined based on the online metrics that we talked about earlier. Remember when I said once you set up the ML problem, the correct ML problem, this will give you the ability to define the metrics that you will track. Maybe you will define metrics like basically number of active users, or something like number of conversations that we have, like number of turns in the conversation, or anything like that. If you if you're not satisfied with the metrics, basically the system is not doing what's supposed to be doing, you start tweaking few things in the system. So for example, let's take the RAG or the retrieval augmented generation architecture that we had. If we are not satisfied with the quality of the system, what are the things that we can change? If you're not satisfied with the quality, what are the things that we can change in a retrieval augmented generation system? Dataset is one thing that we can do. Yes. Choosing a different LLM model. Yes. What else? Other than the model, yes, we can play with the vector store. We can use different embedding models. Um, we can also, one of the things that we can change is the prompt itself, right? Remember, we had a specific prompt structure that that was telling the LLM, you are supposed to answer this question based on that information, give the response to me. So there are many moving parts that you can change to basically improve the quality of the model. So, for example, I chose only two things here. There are way more things that we can do. But for example, we can either choose a different model and or a different prompt. From quality perspective, this may improve things. But from software engineering perspective, operations perspective, this will introduce some challenges. What are the challenges that you can think of if we have the option to, let's say that we're limiting ourselves to only change the model or the prompt? What would be the challenges from system design or from operations perspective? Scale will be a problem regardless of like we changing the prompt or not. But if you think about it from maintenance perspective, uh, we will lose track unless we have a proper operations systems. We will lose track of which model was used with which prompt. Let's say that you are running an experiment and you want to release a new prompt for only 10% of the users. Uh, Quickly, if you do not have a proper maintenance or proper versioning system, you will lose track of which model was used with which prompt, which is an important aspect of designing systems. It's not only about the quality at this point, it's mostly about maintaining consistency. So you can think of this as, in our system, the LLM and the prompt that is tailored for this LLM, that has been engineered for that LLM. These two have to be consistent with each other. In another word, you can think of these as a bundle, and you need to version that bundle that is consistent with itself, so that you say like v0 of the model config is this specific model version with the specific prompt. If I want to release a new bundle, I will release the combination between them. Think of this as releasing a new binary for your server. There are best practices that people do to maintain the rollback compatibility. All the best practices that you learned about in software engineering can be applied here. And this is where actually ML engineering comes into the picture. It's not only about achieving the highest quality, but also about maintaining a system. Because In reality, it's not one person. It's not only a one person who's working on that system. It's a team of or a number of engineers. So thinking about these versioning problems and these operations problem is actually very important if you want your product to be successful on the long run. Okay, so basically we talked about the idea of monitoring whether the system is good enough or not. You go through the initial launch and you do model or prompt or prompt updates, and you maintain the versions compatible with each other as a bundle. And we rely on the online monitoring that we mentioned previously to know whether the system is doing what it's supposed to be doing or not. Um, what would you recommend as a metric to track to know whether the whole end-to-end system is working as intended or not? What do you folks think? What are the metrics that we should be tracking as business metrics, not ML metrics, to know whether the model is doing what it's supposed to be doing or not? Latency, yes. Accurate response. How would you define accurate response if you're if you have deployed the model already? Remember, the online metrics have to be something concrete. It can't be something like user satisfaction. I don't know how to measure user satisfaction. It has to be something that I can measure. So latency is something that we can measure. It's something that we can plot on a curve. But basically, in terms of the how the users are using the system, we need to come up with some metrics that we can measure on using online metrics. It's not offline, which means we cannot use precision, we cannot use recall because we don't have ground truth for online metrics. So F1, precision, recall, and everything, like these can be used for offline metrics, but they cannot be used for online metric. So basically, the things that we can track is number of active users. This is something that we can track. And in theory, it has a correlation with the quality of the responses that we get. You can see here that it doesn't directly depend on which model you're using. It just depends on whether we are achieving our business goals or not. Another thing is number of turns. Like, are people using our virtual assistant and ask it a question and they realize that this virtual assistant is too bad and they abandon it? Or are they actually engaging in a meaningful and useful conversation, which is reflected in the number of turns? Think about if you're using ChatGPT and it gives you a useful answer, you can ask a follow-up question and make a longer useful conversation versus realizing that it's too bad and you abandon it. So that's basically what number of turns is capturing. Another metric can be containment rate, which is basically the ratio of the conversations that have been resolved without escalating to a human. So if you have like an option to say like talk to a human, you want this to be used less, because if it's useless, it means that people got what they wanted from your virtual assistant. So the higher the containment rate, the better the system that you have. There are so many online metrics that you can think of. I just wanted to give you an idea or some suggestions on what online metrics should be there. It should be measurable. It can't be something vague like user satisfaction. And it should also be related to the business requirements. If you have, like, let's say, I want all the answers to be delivered to the user within 500 milliseconds, then you want to measure the average latency and you see whether you're meeting the requirements or not. The last thing that I want to talk about before handing it over to Rohan is realizing what people have mentioned about privacy, security, and specific compliances. Different domains have different compliance requests or compliance requirements. Almost all of them, especially if you are deploying this for enterprise users, all of them require being very explicit whether you're using their data for training or not. Almost all enterprise customers uh, do not allow using their data for training, so you have to comply with this. Some additional domains like finance have like a regulated domain which requires some legal obligations. Some domains like health require some compliances like HIPAA compliance. You should be aware of these, but the biggest constraint that almost all enterprises have is you shouldn't be using their data for training unless they know and approve that. Almost all their applications require factually correct answers, and you should have them at least offline evaluation to measure this and ensure that this is actually the case. And of course, you should have no biases against a specific group. And this is a known problem with LLMs because it's trained on online data, which contains already biases. There are some debiasing technique that goes into the training. You can check out these techniques out, but it's one of the concerns that people have before launching any virtual assistant. They have to do some safety evaluation to see if the model is giving unsafe answers or already has like an explicit bias. So That's all what I had. I will just wrap up the conversation and then I will take some time to answer your questions offline, typing answers for you. Just quickly to recap what we talked about, AI or ML system design is not only about building models, it's an end-to-end system. You have to think about what are the inputs to the system, what are the outputs and the main components. And once you deploy that system, your job doesn't end. You have to maintain it. You have to think about the operations and how the updating the model will be easy and whether it's rollback compatible, backward compatible or not. And you should also, especially for safety, for GenAI, you should think about safety and security. Uh, that's all for me. I will hand it over to Wuhan now, and I will take the time to answer the questions that people put in the Q&A offline.
Thanks, Ahmed, for taking this up and really appreciate you walking folks through the context. So, folks, just to give you like an interim check, this is the core content for today. But that being said, there are a lot of questions which have come from you, be it in chat and Q&A. We'll like take a moment to address those. And before we do that, there's one special announcement that we have for today. Just give me a sec. Let me share my screen. Um, Give me one sec. There's so many tabs open. Yeah. There is a masterclass on my screen is visible. One second. Is my screen visible?
Yeah.
Yep. So there's a masterclass. I think this is why I was saying like please give me like the accurate responses in the beginning. Like 57% of you mentioned initially that you want to learn how to work with LLMs. So there is a masterclass on 7th of October specifically on this problem statement. Which will predominantly cover making smarter LLM model choices with proven frameworks. This will be led by Dr. Nahid Farhadi. She's a principal software engineer. She has worked at Google, currently working at Microsoft New York. Again, based out of US, super early call for her. But she has agreed to take this masterclass with us. If you are interested in this master, this is on 7th of October at 7 p.m. IST. Do drop in a yes. We'll be happy to send you the invites. Even if you haven't, by any chance, you miss out responding yes or something, we'll be happy to send you registration links otherwise so that you can make an informed call. But that being said, this masterclass is on 7th of October. If you're interested to know more about it, if you want to join this, drop in a yes. I'll just keep the poll live for in a minute. Then we'll have Swati with us. Swati will walk you through the industry trends. How is the industry shaping up, predominantly the tech sector, specifically with regards to the advent in the AI domain? What are the sort of skills that are needed today to stay relevant? And also mention a few pieces about Interview Kickstart's offerings in that front. Swati, over to you. I'll end this poll in a minute and then I'll launch a new poll, folks. And then Swati's content will take, I would say, around 5 to 10 minutes, plus minus here and there. Then we'll have Ahmed back with us again, wherein we'll cover the questions. We'll take some live questions with you folks. So do stay tuned. And there's a special announcement in the end for you folks. Over to you, Swati.
Hi, everyone. Good evening. Let me start by introducing myself. My name is Swati, and I've been working with Interview Kickstart for over 5.5 years. During my tenure at Interview Kickstart, I have worked with both US and India, so I understand the market really well. I have spoken to approximately 70 to 80,000 engineers like yourselves, and I've helped approximately 18,000 engineers transition into Fang Plus companies. So here at this point in time, I am leading admissions and careers. I would be here with you for the next 5 to 10 minutes, and I'll try to take you through the industry trends and how can we help you out at Interview Kickstart. So let me start by presenting my screen. Just give me a moment. All right. I hope you all can see my screen.
Yeah, we can, Swati.
Awesome. All right, folks. So as I mentioned here at Interview Kickstart, broadly, there are two things that we do. Firstly, we can help you out with your interview preparation. What we can do is we can help you out in firstly preparing for Mang Plus interviews and also help you out in being AI enabled in your respective domain. The second thing that we do with you is we help you out in completely transitioning into AI ML at this point in time. Let me quickly get started with the main presentation. Yeah. So what we've seen in the past couple of months is, firstly, what we do is on a daily basis, we speak to industry experts. We speak to a lot of engineers who are working in these companies. So if you take a look at the graph over here, it's clearly visible the investment that is being done in AI at this point in time, it has drastically improved, right? If you see in 2021, approximately $25 billion was invested in AI. However, if you take a look at 2025, almost $81 billion is being invested, which is actually expected to grow to $1 trillion by end of 2025. Now, what that represents is the kind of amount that is being invested in AI, which also translates to the job in demand at this point in time, right? Now, this investment can be broadly classified into three main important models. First is AI infrastructure. So of this investment, at least 60 to 70% is being invested in AI infrastructure. What does that mean? So at this point in time, infrastructure basically dominates, right? Because a lot of these companies, they are looking to build scalable data centers. A lot of money is going into investing in GPUs as well. The second important component is, at least at this point in time, 20 to 30% is going into model development. We have already gone through various versions of GPT. Now we are at GPT-5. We also have AI agents. So the pace which with the reiteration is happening in model development, that is slow. However, that's something is still happening over there, right? However, the important aspect is industry-specific solutions, which is 5 to 15%. This is an important layer. This is an exciting layer because we already have agentic AI, we already have generative AI. Now, what we can do is we can deploy these models into various industry. Just yesterday, I was speaking to somebody who works in aviation department, and he was talking about how they are actually thinking about deploying some of these models in Air India. Similarly, there are a lot of other use cases as well. We can deploy this into telecom, we can do this in fintech, we have supply chain management, logistics, and so on. So what this represents is that at this point in time, there is huge demand for GenAI engineers. If I have to quote some data, we were looking at Westcop 2024 data. At this point in time, we have only one Gen AI engineer for 10 job requirements. So what these companies are saying is, let me just move on to the next slide. All right. So what these companies are saying is we did other research, which was Future of Jobs 2025. ML, AI, and data science roles have already increased up to 5x. If you see the graph over here, LinkedIn job openings. So these roles have already increased. What we can also see is, along with this ML, AI, and data scientist job spike, the other job role, interestingly, that's also increasing is data engineers. The reason that's happening is the more that we have people building models, they would also need a lot of data engineers to build data pipelines. So that has also grown a lot in the last few months. And as you see, the projections is basically expected to increase till 2028. All right. Now, what's also happening is a lot of this investment is happening by top tech companies. Those are MAN companies. A lot of this investment, the one that we saw earlier, $80 billion, that's by Meta, that's by Google, Microsoft, Amazon at this point in time. The reason that's happening is because these companies are taking core projects which are dependent on AI, like recommendation engine that you see on Netflix, Google search on Google. You see Gemini is now integrated in Google search. The moment you type or you search for anything in Google, Gemini gives you a recommendation. Then you have Alexa. We also have Siri. So a lot of investment is going on into this project, and that's the reason a lot of these companies, they are hiring for AI ML engineers, they're hiring for data scientists, they are looking for a lot of AI enabled data engineers who can support these AI ML roles. If you see on the screen, you see software engineering manager, Meta is looking for, if you see Adobe, they're looking for computer scientists, Amazon is looking for team manager in ML data ops, Microsoft is looking for principal applied scientist. I'll just give you all a couple of moments to take a look at this, and then we can move to the next slide. All right. So one thing that we have seen, we have always seen is whenever there is a lot of demand, but lesser supply, whoever has that skill automatically gets paid really well. And that is something that's being represented in the graph as well. If you see across L3, L4, L5, L6, and L7, there is huge difference in the compensation that you can get if you're a traditional software engineer, or if you're somebody who's AI enabled, or if you're somebody who's into AI, ML, or data science roles. Now, this makes a significant jump if you're somebody who is, say, at a L6 level, which is a staff engineer, or L7, which is a senior staff engineer. So if you can see the gap in the pay, that's upwards of 35 LPA, which is huge. What does that mean? That means that if you're somebody who has AI ML expertise, that puts you in the top earning bracket. That's why we recommend everybody to actually upskill themselves in AI ML at this point in time. Or if you're somebody who's, say, a backend engineer who's into DevOps, or if you're somebody who's an engineering manager, at least build that AI capability. Let me quickly move on to the next slide. All right. So now with this increased investment, we are seeing that there are three different layers. So the first layer that we see is core AI model development. So these are the professionals who typically focus on creating and refining AI models. Who are these people? These are the people who would be building AI models. So they would be AI researchers, data scientists, and ML engineers. Now, the next layer that we see, these are AI infrastructure and operation layer. So these roles enable scalable deployment and operations in AI system. You would see on screen that you have ML ops engineers here, right? One thing that we are observing in the past couple of months is a lot of DevOps people are moving to ML ops, and that's a natural transition. On a daily basis, at this point in time, I come across at least 5 to 6 people who are looking to move to ML ops. And reason being, the slide that we saw earlier, people who are moving to ML ops, the kind of compensation that they get is much more than what a typical DevOps person would earn. If you're somebody who's AI infra engineer, you fall under this. If you're somebody who's a data engineer, you would also fall under this bracket. Now, the third bracket that we have, this is AI application development. This is somebody who is building practical application using AI models. So remember, I was talking about if you're somebody who's a backend engineer into aviation, if you're somebody who is working into, say, healthcare, and you want to use these GenAI models to deploy on your app, then this is here you fall. You would be AI application developer, you can be an AI product manager, and there's a lot of rising demand in each and every domain. All right, so this kind of resonates with what we already spoke about. So what we did is we took a look at 5,000 JDs on LinkedIn. We got this data from LinkedIn, and we just wanted to observe what kind of roles are increasing and which kind of role are asking for AI enablement at this point in time. So surprisingly, if you take a look at this graph, you can see that 51.5% of data engineers are required to know AI ML at this point in time. If you take a look at software engineer, that's 36.9. If you take a look at engineering manager, that's 26.9%, full stack product manager, cloud solutions architect, and so on. This is a data which is a bit dated, which means like 3 months back is when we were analyzing this. This has increased further at this point in time because when we take a look at LinkedIn, we see more job roles asking for this. So that's why, again, we highly encourage people to actually either AI enable themselves or move to AI ML. So we also understand that it's very difficult to actually pick on what would be a right pathway for you. So let me just quickly go to my next screen. All right. So we actually took a look at a lot of JDs, as I mentioned, and I'm not going to cover everything, keeping the time in mind, but I'm going to take you through the software engineering job role over here. So if you take a look at the two job descriptions that I mentioned, both of them are asking for AI ML knowledge. So if you take a look at senior staff software engineer at LinkedIn, they are looking for AI ML integration. Now, what do these companies expect you to do? Firstly, I've also mentioned the points on the left-hand side. Firstly, you should be able to build autonomous AI agent and multi-agent systems. You should be able to develop multi-model AI application. You should be able to deploy and scale AI models in cloud environment. And like we just had a session, RAG, LLM, orchestration, LangChain, Llama indexes, one of them. Now, I would also like to cover engineering leaders. We do get a lot of engineering managers who are actually trying to understand at this point in time, how can they use AI in their job role, or if it's even important for them to understand AI really well. So the answer is yes. If you take a look at two job descriptions over here, the first one is by Coinbase, the second one is by LinkedIn. Both of them are asking you to have a AI hands-on experience. The expectation from you would be leading design, development, and deployment of GenAI solutions. You should also be able to ensure scalability, maintainability, and optimization. As an engineering manager, you may or may not be leading ML teams, but you should be able to understand how to make those build versus buy decisions because like we understood, security is something that's also important. So are you somebody who would be encouraging your folks to build models inside, or would you be building on existing models? So these are the kind of decisions that you would have to make. So it's important for you also to have that AI ML aptitude. Now, if you're somebody who's from a domain which is not covered here and you want to get more information about that, you can speak to your program advisor or you can write to us. We would be able to share the details with you on how would it be helpful in your domain. But we do have that for product manager, we have it for machine learning engineers or data scientists, we have it for data engineering, we have it for TPM. So what we have understood, and I'm pretty sure you all would have understood by now, is that no one size fits all. Depending on where you are and where do you want to get to, your pathway would differ. So that's what we are trying to cover here. Firstly, who can you be? You can be somebody who has 0 to 5 years of experience. You would be either IC, you are a software engineer, mid into your career, or you're somebody who's a product manager. Or if you're somebody who's say 15 years of experience, you're a specialist, you're a staff or principal engineer, or you're somebody who's at a senior level. You can be somebody who's an engineering manager, director of engineering, or a VP of engineering. Now, what's your goal? You can have two goals at this point in time. Either you're somebody who wants to switch to ML and data science. That means you want to change your domain completely into AI ML, or you're somebody who wants to build on your existing skills. So you're somebody who wants to be AI enabled backend engineer. You can be somebody who wants to be AI enabled data engineer. So there would be two different paths to where do you want to get to. So let's cover the first thing first. So first we have flagship ML program. And the second program is transformational GenAI for engineering or tech professionals. But I'm going to get started with the first one. So first one is you're somebody who wants to transition into ML completely. For that, we have something called a flagship ML program. Now, let me just quickly take you through how does the program look like and what would be covered as a part of the program. So firstly, the ML flagship program is for 6 months. Then you have 4 months of interview prep that is built into the program. So if you take a look at the schedule that is mentioned over here, we get started with the month 1, which is Python basics. We do get people who don't understand Python at all. So if you're somebody who falls under that bracket, you can get started with Python basics. If you're somebody who's already aware of Python, you've been coding in Python, then you can skip this part as well. You can just probably do a refresher and you can move to the month 2. In month 2, we cover ML engineering and case studies. Month 4 and 6 would cover GenAI, agentic AI, and you'll have some capstone projects. Month 7 to 10 will focus on your interview prep. And you would also see that we have some focused add-ons. You can choose something that aligns with your goal. That can be advanced NLP, that can be advanced computer vision. You can pick up ML ops, you can pick up big data with Apache Spark. Now, at Interview Kickstart, one thing that we believe in is building. So what we don't want you to theoretically go through AI. We want you to build with us. Yeah. So that's why we have 3 different segregations as a part of your program. First thing is very important. That's your workshops. Here you would have live coding with instructors. So there are 3 different things that you would do. You would have smart price AI. You'll have intelligent targeting system. You would have image classification. Second thing is case studies. These are self-guided projects. So these are the projects that you would do on your own. If you have any questions, you can definitely schedule technical coaching sessions, take help from instructors. There are 2 things that you would cover over here. First would be a fraud detection system. Second would be a movie chatbot. Third important thing is capstone project. So let me just remind you the way we build these capstone project. So when we started building these capstone project, one thing that we did is we did a lot of research around it because we did see a lot of programs that are available in the industry, in the market. Those were more of they were not hands-on project, they were more of a theoretical project. So we understood, and if I have to give an example, I was just speaking to our HR team yesterday. And so in our company, like as Interview Kickstart, we also do hire a lot of ML engineers. And what they mentioned is just to hire one ML engineer, they actually rejected 60 candidates. So approximately 100 people gave interview, of which 65 got selected, and they rejected everybody else. They hired one. So that's the amount of skill that is required to actually get shortlisted. And for that, the way you would do that is only if you have hands-on experience. So that's why the capstone project is really important. There are different projects that we provide you. First is browser analytics, Fraud-Sheet, fashion assistant, and Medibot. After you do these projects, you would get real hands-on experience on how you would have gotten if you were working in any of these top tech companies as an ML engineer. So that's the power of the capstone project. It's not going to be easy, but once you do this, no matter any interview process that you go in, you'll be able to explain it really well because your fundamentals would be really clear. All right. So the second important offering that we have is, as I mentioned, if you want to be somebody who's AI enabled in your respective domain, in that case, you can pick up transformational Gen AI for engineers or tech professional. Let me just quickly take you through on what we cover as a part of that. So transformational Gen AI for software engineers. Again, there's a different curriculum for people who wants to be AI enabled software engineer. If you're somebody who comes from data engineering background, then your curriculum would be different. If you're somebody who comes from, say, engineering manager, TPM, director of engineering, then your program would be different. I'm just going to cover only for software engineer in the interest of time. If you want to understand what do we cover for your particular domain, all you have to do is just speak to us. We'll be able to share the detailed curriculum. But it would more or less remain same. There would be some customization basis on your domain. So now, as a part of your transformational Gen AI for software engineers, it would be a 14 weeks program. Week 1, week 2, again, would have Python basics because Python is the base for your ML and Gen AI. So that's why we cover that first. Then you'll be moving on to building foundational AI agents. Then you'll build advanced AI agents, and then you move to your domain-specific capstone project. One interesting thing that we provide you is we let you bring your own projects. So if you're somebody who has a use case in your current company at this point in time, you can bring that to us. We can discuss that with you in detail, and we'll be able to assign a technical coach with you. You can discuss your projects with them, and they'll be able to guide you and help you out in doing that. Now, the other important aspect is interview lab, right? We understand that after you learn everything, it's also a different skill to actually crack interviews in these top tech companies. So whenever you go for interviews in these top tech companies, there are a couple of skills that they assess you on. First would be your problem solving skills. Now, how do they assess your problem solving skills? That's via your coding. That's why we have data structures and algorithm that is built into the program. We have 10 weeks of data structures and algorithm, wherein we start by sorting, searching, recursion, trees, dynamic programming. All this would be covered in detail. And the way we teach you is via power coding patterns. So if I have to give an example on what power coding patterns means, right? So if you take a look at sorting has, say, 10 algorithm. You have heap sort, bubble sort, merge sort, but any question given to any sorting algorithm can be solved using only 4 power coding patterns. What are those? That's transform and conquer, divide and conquer, brute force, and there's one more that I'm forgetting. But the way we teach you is, whenever you go for an interview process, any given coding question that you get, you'll be able to solve it just by identifying which pattern to apply. You'll be able to write the pseudocode and then eventually write actual code, compile it, and run it. So that's the power of data structures and algorithm, because whenever you go in these companies, first you'll get a coding question as a part of the interview. You'll be able to solve that, and then the instructor is going to cross question you, then make a couple of changes. So if you're somebody who does not understand data structures and algorithm really well, if you're not a good problem solver, you would not be able to clear the interview. So that's why we cover this in detail. Then we have system design, and then we move to your domain interview prep. So if you're somebody who's from a backend, then your domain would be backend. If you're somebody who's front end, then it would be front end, and so on. What we also have as a part of the program is your resume, LinkedIn optimization, and mock interviews. So we have a detailed placement assistance that is built into the program. As a part of your placement assistance, we would help you out with your resume optimization, LinkedIn profile optimization. We help you out with your application strategy. We help you out with your salary negotiation as well, plus mock interviews. So mock interviews are an important component of the program. These are replica or simulation of your actual interview. The way your interview process is going to be in any of these top tech companies, we replicate the same process. This is going to be 1 hour long. It's going to be really tough. And this would be with the folks who are actual hiring managers and technical leads from the top tech company. So you get relevant feedback. Once you get that feedback, it helps you out in improving, scheduling more technical coaching sessions with the instructors. You